Why Earth never started over again. There were many moments when the story could have ended. Fire, ice, impact, and extinction all came close to erasing everything. Yet the planet never truly reset. By the time Earth reached its modern form, it had already endured more destruction than most worlds ever experienced. This matters because survival alone does not explain continuity. Many planets survive catastrophes, but lose everything that came before. Earth is different because even its worst disasters failed to wipe the slate clean. Something always remained. That persistence is not a coincidence. It is a result of systems that evolved specifically to carry complexity through catastrophe. Mass extinctions tore through life repeatedly, eliminating dominant species and collapsing entire ecosystems. Asteroids struck with planet-altering force. Supervolcanoes darkened skies and froze climates. Yet after each event, recovery followed faster than the last. Complexity returned, not from nothing, but from remnants preserved through depth, diversity, and redundancy. The survivors of each disaster carried with them the accumulated innovations of everything that had come before, giving recovery a head start that pure chemistry could never provide. The reason lies in how Earth's systems overlap. Oceans shielded life from radiation and heat. Continents fractured habitats instead of concentrating risk. Atmosphere and climate dampened extremes instead of amplifying them endlessly. No single catastrophe could reach everywhere at once. This geographic and environmental diversity created a network of refuges, ensuring that even the most devastating events left pockets of complexity untouched. Time played its role again. Long intervals between global disasters allowed recovery to compound. Each rebound rebuilt stronger networks of interaction, making the next collapse less absolute. Earth was not avoiding endings. It was learning how to limit them. The planet had crossed a final threshold. It could be wounded, but not erased. This resistance to total reset was not accidental. It emerged from the way Earth's systems became layered and interdependent over time. Life spread into oceans, soils, rock pores, and the atmosphere, occupying spaces that disasters could not reach all at once. When one environment collapsed, others endured, carrying memory forward through survival rather than dominance. The sheer variety of habitats meant that extinction in one region did not necessarily mean extinction everywhere, and the connections between surviving populations allowed recolonization to begin almost immediately. Climate feedbacks also played a crucial role. After extreme warming, weathering and biological activity slowly pulled carbon from the air. After deep cooling, volcanic gases rebuilt warmth. These opposing forces did not eliminate catastrophe, but they shortened its reach. Extremes became chapters instead of conclusions. The planet's ability to swing between states without permanently settling in either one demonstrated a kind of resilience that went beyond mere toughness. It was structural, built into the way energy and matter cycled through the system. Evolution responded by favoring flexibility. Life diversified into countless forms, strategies, and niches, reducing the chance that any single event could erase everything. Resilience replaced perfection. Survival favored systems that could lose parts without losing function. Earth's biosphere became modular, capable of damage without collapse. This modularity meant that when catastrophe struck, the planet did not need to reinvent life from scratch. It only needed enough surviving pieces to reassemble the puzzle in a new configuration. Even geology adapted. Plate tectonics prevented stagnation, recycling nutrients and reshaping habitats without destroying them entirely. Continents moved slowly enough to challenge life, but not fast enough to erase it. The planet remained dynamic, but never blank. What emerged was a world that carried its past forward, even through devastation. Earth stopped starting over because it had learned how to preserve fragments through chaos. And fragments, given time, were enough to rebuild everything again. As these fragments accumulated across deep time, recovery itself became more efficient. Each rebound inherited structures, relationships, and chemical pathways refined by earlier worlds. Life no longer rebuilt from simplicity, but from layered complexity that could be reassembled in new ways. Extinction cleared space, but it did not clear memory. The biological innovations preserved by survivors became the foundation for new ecosystems, each one more intricate and more resilient than the last. This compounding effect reshaped evolution. New forms emerged faster, adapted more quickly, and integrated into existing systems rather than inventing everything from scratch. Food webs were formed with greater density. Ecosystems regained function before reaching former diversity. The planet remembered how to be alive. Each recovery was not a return to the past, but a step forward, building on lessons encoded in the survivors of every previous crisis. Geological stability reinforced this momentum. Continents remained, oceans persisted, and the atmosphere stayed within narrow bounds that allowed continuity. Even when climate shifted violently, the underlying framework endured. Earth's surface changed, but its operating system remained intact. The tectonic, atmospheric, and oceanic processes that regulated the planet's conditions continued to function through every disruption, providing a stable foundation on which biological recovery could build. The build-up toward this realization marks the emotional peak of Earth's origin story. Survival had become cumulative. Each crisis tested limits, but also strengthened the systems that followed. What once would have erased everything now reshaped only parts. The planet had reached a point where even its worst moments contributed to its future rather than negating its past. Earth had crossed beyond fragility. It was no longer a world that needed perfect conditions to survive. It had become a world capable of enduring imperfection. And that capacity would define everything that followed, including the rise of intelligence capable of recognizing this history at all. The climax of Earth's long origin story is not found in a single miracle, but in persistence itself. After billions of years of near endings, the planet reached a state where continuity outweighed catastrophe. Change arrived violently, but it could no longer erase the accumulated momentum of the world. Earth had learned how to carry itself forward through damage. Every layer of rock, every fossilized remnant, every surviving lineage testified to this capacity, a record of endurance stretching back to the planet's earliest days. The resolution lies in what this means for the present. Every forest, ocean, and living system exists because Earth never truly reset. The ground beneath us holds memories of ancient failures and recoveries layered on top of one another. Life today is not the result of a perfect past, but of an imperfect planet that learned how to recover faster than it could be destroyed. This history reframes how we see Earth now. Stability is not guaranteed. Resilience is not infinite. The planet survived because its systems had time to respond, adapt, and correct. When those systems are pushed faster than they can adjust, the balance that once saved Earth can begin to fail. The same feedback loops that restored the planet after each crisis depend on pace, and when the pace of change exceeds the speed of recovery, the outcome is no longer certain. Earth never started over again because it learned how to remember. It preserved fragments, allowed recovery, and turned survival into a cumulative process rather than a fragile one. That lesson is still unfolding, written into every cycle that keeps this world alive. Sometimes the smallest shift in perspective becomes the beginning of a new future.